Today I will be going over how our supervised guardrails can help prevent important data leakages in your LLM systems. We will be using medical data and a medical guardrail agent to showcase these features. Our agent is a very simple assistant agent that will be connecting to two separate knowledge bases. One unstructured text knowledge base, the other is our predetermined live dataset. As a disclaimer, these two knowledge sources and dataset are all synthetically generated demo data. If you are dealing with actual medical data, it is recommended that you use a privately hosted model or privately hosted LLM model. In this case, we are using an OpenAI GPT 4.1 model to showcase the supervised capabilities in this demonstration. Again, if you are using actual medical data, you must be using a privately hosted model in accordance with HIPAA. So our agent is a simple information medical assistant. It's connected to two knowledge sources: medical knowledge base, which is a collective of general educational information about various medical conditions, symptoms, common treatments, and lifestyle advice. The second knowledge source is patient records dataset. This is considered to be our live dataset, which collects all of our medical data from our system should we be in an actual medical environment. When answering these questions, we assign it some answering guidelines. Use the knowledge base provided. Always respond in a clear and friendly professional manner. Keep responses concise and accurate. Do not assume user intent beyond their question. Ask them for clarification if needed. In our Tools tab, we can see how our agent is connected. We can see our medical knowledge base is a knowledge source, and our patient database is connected to our BigQuery demo data source. We are using Google BigQuery for this demo data. That is where we normally store our data. Here is the actual demo data which we will be working with. We have 20 records of patients, and we have our medical knowledge base containing 20 different symptoms, afflictions with brief notes. Again, these two documents are synthetically generated and for use in demonstration only. We can showcase our agent in the chat playground. We can test different responses, how it responds to different requests, questions, inputs, etc. Let's ask it some pretty general safe questions at first. For example, what are the common symptoms of asthma? In this case, it will be connecting to our medical knowledge base as a source of knowledge. And there it gives its response with some basic information regarding asthma. We can also ask it, how is cholesterol usually managed? Again, it's using our medical knowledge base to answer the question, and it is not diagnosing, but just simply giving advice. Finally, we can also ask it maybe a question regarding our patient database, such as, how many patients in the database have hypertension? It's a pretty safe question. There's no specifics towards the patients. We're asking a general aggregated question on our overall data, and it responds with saying there's one patient in the dataset with hypertension. Now, I've purposely avoided setting up the guardrails for now, which to showcase how the guardrails are needed when asking some dangerous, unsafe questions. First, we can ask it a very specific question regarding one of our patients. What is patient 1 currently taking? What medications are they taking? This is a very patient-specific question, obviously, and usually should be blocked. However, since we have no guardrail set up at the moment, it will probably answer the question. And here we can see patient 1 is taking those two medications. Now, any sort of user, this information would be helpful towards doctors or certain medical assistants, but other people may not be allowed to see this information. So normally we'd want this type of question being blocked by a guardrail. However, one interesting aspect about GPT models is that they have some already built-in protection guidelines in their model already. And we could showcase this by asking other questions. For example, one of our synthetically generated patient is named Mary Johnson. We can ask, what city does Mary Johnson live in? Here we can see that the LLM agent cannot answer the question because it is asking some personal information. This is a showcase of how the GPT model does have some inherent blocking ability already with regards to medical data. However, as we can see with the first question, it is still inconsistent and thus guardrails are necessary. We can also ask it another question regarding diagnosis to show how we're trying to access some medical knowledge base, but we're asking it to diagnose us, which should only be done by a doctor. Here we can see again that it cannot diagnose us. It gives us an response. Again, showcasing the already blocking millions of GPT models. But again, we need our guardrails set in place to avoid certain questions like question 1 from being answered. Now we can set up our guardrails very simply by adding them. We have 6 options here for input and output toxicity, restricted topics, and allowed topics. We will be using restricted topics, both input and output today, to kind of add 2 more folds of security towards our LLM agent. We'll begin by looking at output first. First, let's handle some patient level information. So we can name our guardrail patient information output. And we specify some topics that should not be covered by the LLM agent. In this case, we don't want it to ask patient-specific medication questions. We also don't want it to answer any patient demographic questions. Additionally, we don't want any identifiable patient information being released. Now you can make these topics short, simple phrases, words, sentences. The key to guardrails, though, is connecting to a GPT model, or any sort of model. Here in this case, we'll be using a GPT one. Again, as a disclaimer, since we are using synthetically generated demonstration data, we will be using an OpenAI model. Again, if you are using your own medical data that's real, you must be using a privately hosted model through our OpenAI compatible feature. In this case, still, we'll be using an OpenAI model, again, because it's a demonstration to showcase the ability of a guardrail. Let's select GPT-4o. Make sure you have your OpenAI token or whichever token that you have for your model. Now that we have our patient output information guardrail, let's ask it again. What medications is patient PAT001 currently taking? And here we can see your message has been blocked due to a guardrail violation. Please rephrase your message and try again. Great, that's what we want. We can also set up our diagnosis request guardrails, as you can see here. Simple diagnosis requests should handle it. Again, we're connecting to our OpenAI model for demonstration purposes. And here we can see our guardrails working perfectly. Our message has been blocked due to a guardrail violation. Please rephrase your message and try again. Notice how we are creating input and output guardrails for both of these topics. It is important if you want extra security to have twofold, in this case, input and output, as well as whatever built-in GPT settings are in there. Using the guardrails capabilities, you can ensure that any sort of questions like this will be blocked. Now you may be wondering, we've set up an output and input guardrail for medications, but we still want to figure out, well, what type of medications are present in the database and how many of each are there? Well, let's ask. As long as we're not asking a patient-specific question regarding it, the guardrail should allow it to pass through. And here we can see all the different types of medications present in the database. As part of Superwise's observability features, we are collecting data from each of your agents that are active through their chat here. We can explore this data in our Explore page, found here. Using our medical guardrail demo, let's check some different various statistics we can look at. We can check all the fields, we can check different answers, we could check the agent ID, questions, timestamps, violated guardrails, if the guardrail is violated or not, response time, etc. We can check different values of the questions, of the answers, toxicity, text length, hashtag count. There's a bunch of different statistics that we can collect and view on our Explore page here. Let's check to see what type of questions have been asked to our agent. So select the question. Let's make it raw data for now. Make it a table. Don't want to filter them at all. We just want to check to see what questions were asked. And we click run. Okay, we can see what type of questions we've been asking our agent. How is high cholesterol managed? How many medications is Mary Johnson taking? Some of the disallowed ones, some of the allowed ones. We can also check to see, okay, is this a guardrail violation or not? So let's add that to our fields and click run again. Great, now we can see which questions are matched up to violated guardrails. We can see both the before and after effects of when we implemented our guardrails in the previous demo. For example, here, what medications is patient 1 taking? We see the first time we asked it, false, because there's no guardrail. Then we set up the guardrail, and oh yeah, look at that, it's true. Now you may be wondering what this Add Dashboard button means here. You can add these widgets to a dashboard to create one overarching view of your agent. Now we can add our dashboard, or add our widget to our medical guardrail demo dashboard. Let's name this questions asked, and done. And it's saved to our dashboard. So here we have our dashboard. This dashboard is constantly updating to provide you with the most live, accurate data from your agents. We've already set up 4 widgets here, and they'll load in just a moment. We've got our questions asked widget we've just created, the guardrails violated in the past day, a response time distribution histogram so we can see the performance of our agent, and what guardrails were violated. Great, now we can see our widgets in action. So again, we can see our questions asked and next to our guardrail violated field. We have our guardrails violated the past day. We can see we started off high, went down for a bit, and then had one violated recently. We can see our response time histogram. The buckets are already created by the system. And we can see which guardrails were violated and how many times each were. Now you may be wondering, why are there multiple patient information input rows? Well, it's because different aspects of the guardrail, different topics of the guardrails were disallowed at different times. So in this case, we had one request for identifiable patient information, and that was blocked. But we can see down here, we had 2 separate requests for patient-specific medication questions. Those 2 were both blocked. We can also see our diagnosis request input is also working properly. It's not allowing users to request for diagnosis for them. And finally, we can see that it is preventing questions that are asking where patients live. Next, I'll be showing you how we can create policies to help alert us of when our systems become unhealthy. In this case, we've created a policy to detect how many guardrails or how many times a guardrail is violated in the past 5 minutes. It alerts us whenever this value goes above 0. So if there's 1 guardrail violated in the past 5 minutes, it'll make the system unhealthy and then send us the alert. Again, we can see our unhealthy condition is defined by when any value is above 0, and those values being if the guardrail is violated equals true from our medical guardrail demo chat. Again, from the data that we're collecting, if a question is asked in the past 5 minutes that violates a guardrail, it'll change the system from healthy to unhealthy. The alert is being sent to our designated Slack channel. Currently, we support connections to Slack, and we can connect to our different Slack accounts through our destinations tab found here. You can set it up to a certain channel or whichever you have in Slack that you want to send to. And when we're selecting a destination for a policy, we just select, okay, we want it to go to our demo alert policy destination, which we've created. You can create policies to alert you for any of the different metrics that are present in our data. Or if you want to create your own sort of data sets, you can also create and upload your own data set. And if there's a change to that one, then the policy will detect it. This policy is running every 5 minutes. It is a constant check every 5 minutes. It's not checking every second. So say it checks now, and then 2 minutes from now, a guardrail is violated. We'll receive an alert 3 minutes after that. We can also view our data directly in our datasets page. This dataset is able to be accessed through our Python SDK library. We can view our data, we can add more fields to it, directly fool around with some of the entries, such as the violated guardrails column. We can see that it's a list full of dictionaries. You can do some data manipulation and analysis on it in Python. We can also check the schema here. Check the different data types, the name, default values. We can create our own fields should we want to. Or If we go to our details page, you can see that we can connect to different data sources. This feature is being built upon right now, where you can connect to various different sources to build up your data set directly and have it be connected to your agent's chat. These are just some of the features that we have for working with your agents and observing their performance, abilities, etc. We're constantly making new features in Superwise, and we will always keep you updated with any new features that come out. Thank you.